Good afternoon and welcome back. I know for you, it's probably Thursday if you've been going along at the pace that we had set. My guess is that it is Thursday because these last videos have been a little bit longer. It's okay, I've been trying to figure out my system here, and I'm sure you guys are settling into a new class there and having all the things online and that kind of stuff. I will say, as we're moving forward, there will be fewer examples at the end and more of just the examples inside the lesson. For example, today's lesson, we have many different little topics to cover, all of which you should have covered in Algebra 1 and Algebra 2, depending on which one we're dealing with. But each and every one of these topics should have been covered, so it's not new, but this is a review of quadratic functions and equations. Now, I don't want to take you by surprise, but we're going to be moving relatively fast here, and I'm going to be pointing out a couple interesting tidbits as we go through to help you with the homework. All right, so we're going to start right off with an example here. It says graph using a table of values this function, f of x equals 2x squared plus x minus 3. So I'm going to start off with a table of values, and I will let you know that the easiest values to use are the ones near 0, simply because the math is easier. So I like to use 0 and -1, -2, 1, and 2. Now, for your ALEKS program, you will need 5 points to graph a parabola. So you should get used to making a table of at least 5 points when you're using a table. Here, I've got -2. I don't know, it may take 3 points later on, but if it says graph using a table, it's going to want 5 points. So -2, I'm going to take and plug that in here to find the answer. Same with all of these values. The other thing that I like to do is I like to start in the middle. This does not necessarily mean that these values will always be the same, but I like to start in the middle because it's the easiest to plug in. So f of 0 equals 2 times 0 squared plus 0 minus 3, -3. So I know this is at -3. Next, f of 1 equals 2 times 1 squared plus 1 minus 3. Well, 2 times 1 squared is 2, plus 1 is 3, take away 3, that will give me 0. F of -1. 2 times -1 squared plus -1 minus 3 equals -1 squared will give me +1. So this is still 2 times 1. So I have 2, take away 1, take away 3. So I've got 2, take away 1 is 1, take away 3, that's going to give me a -2. As you can see, these values are not repeating back and forth, and that's okay, they don't have to. Some of them, if they're really nice and pretty, will do that, but doesn't mean that they all will. F of 2 equals 2 times 2 squared plus 2 minus 3. So 2 times 2 squared, 2 times 2 is 4, times 2 is 8, plus 2 is 10, minus 3 will give me 7. And my final value, f of -2 equals 2 times -2 squared plus -2 minus 3. So -2 times -2 will give me +4 times 2 is 8. So this is 8. Take away 2 will give me 6. Take away 3 will give me 3. All right, so now graphing. In ALEKS, when you have to graph this, it will be useful if you click the button that says enlarge the graph. So at 0, I'm at -3. Well, there's -1, -2, -3 is actually down here. So right here, 0, -3, -1, -2, -2, +3, 1, 2, 3, 1, 0, 2, 7, 2, 2, 4, 6, 7. This is not the vertex. If this were the vertex, then these would be exactly the same. This vertex is actually over a little bit, about right there, so that it comes up and it speeds through these points. It also comes up and speeds through these points. Now, I want to stop here for a second and talk to you about some of these values. Do you see up here the -3? That -3, remember these come in the form ax squared plus bx plus c. That c is -3. And notice where it crosses the y-axis here. This is because the y-intercept equals whatever c is. The y-intercept is c. That's what this value is. That will become useful in the next one that we graph, because if I know what the y-intercept is, I know a point without having to plug in a table. There's another interesting tidbit here. I wanted you to be sure to know that the vertex was not on that. That's because there is a line that comes up through here like this. And this is called the axis of symmetry. This axis of symmetry means that from here to here is the same as here to here. Those should match. This one and this one, this is directly in the middle. This we write it as x equals. And then the formula is like the first part of the quadratic equation, -b over 2a. And that's how I remember is the quadratic equation, -b over 2a. Normally you'd have all this extra stuff over here to solve the equation. But this is the axis of symmetry. Now the nice thing is this is also the x value of the vertex. So if you need to find the vertex is this point where it turns. Right here is the vertex. If you need to find that point, you can always use the x value of -b over 2a, and then you find the function of that value. Because you plug it in for x, you plug it into the function, find what the y is at that point, and that is your point, so -b over 2a. Whatever your answer is here, you plug that in for x and you'll get your y value, and that's how you find your vertex. Now, the nice thing about this is once I have the y-intercept, the axis of symmetry, and the vertex, I can start having enough points to graph this without needing to make a table. And this frees me up because I'm not doing all of this math. All this math can just go away. I don't need to do all that math, especially if I can find these properties of x and y, the properties of this function. Also, just to help you know that the vertex is not here, is over and not on there, -b over 2a. In our situation, -b b is 1, so negative b is negative 1, over 2a, so 2 times 2, so I would put here at 1/4. So here, this is x equals negative 1/4. And that's how you would know that it's not on the y-axis. All right, so let's try a problem. It's a different problem, but now we get to graph using the y-intercept, the vertex, and the axis of symmetry. Okay? So looking at this, I'm going to start by trying to find the y-intercept. So the y-intercept. Remember, the y-intercept is the value c. So as I'm looking at this, this would go away because I've got 1 as a, 5 as b, c is 6. So my y-intercept is 6. If I was going to write this as a point, I could write it as 0, 6. Okay, so I already know that this line is going to cross at 1, 2, 3, 4, 5, 6. It's going to cross right here. Then I can find the vertex and the axis of symmetry. So the axis of symmetry, let me bring that back into your view. Axis of symmetry, the formula for it is x equals negative b over 2a. So I'm going to come down here, axis of symmetry equals negative b over 2a. So negative b, I've got 5 as b, so negative b will give me a negative 5 over 2a. So 2 and a is 1. So I'm going to get negative 5 over 2. Now, I like to keep it like this, but it is up to you. You can write this as negative 2.5. Wholly up to you. I don't mind either way. This one or this one will give you the same answer. I like it this way because I can square and work with fractions easier. If you're not used to working with fractions, then you'd rather work with this. For me, I look at this and this is like working with the number 25, and I can work with 5 and 2 easier than 25. So, moving forward, I now have my axis of symmetry is at negative 2.5. So right here is my axis of symmetry. I already know then that as I go through this point and come down, 2.5 the other direction. So here's 1, and I need to extend my line out a little bit. 2, so here's half, 1, 2, and it's going to be up at the same level because the axis of symmetry acts like a mirror across the parabola. The shape of this graph is called a parabola. Now, the vertex. The vertex, in this case, we have to plug this value into f of x. So I have 5 halves negative squared plus 5, and I'm going to write over 1 so that you can see this, times negative 5 over 2 plus 6. So 5 squared, negative 5 squared would give me 25 on top. 2 squared would give me 4 on bottom, plus, here I can just multiply. So 5 times negative 5, negative 25, sorry. Thinking 25, writing 5. Negative 25 over, and then 1 times 2 is 2. Plus, well, you see this is a power of 2, and this is a power of 2. So I can make everything 4s very easy. So 4 times 6 is 24. So I'm going to say 24 over 4. Now, this would simply double. So I'd have 50 over 4. So 25 over 4 minus 50 over 4, that would be negative 25. Let me rewrite this for you so you can see it. 25 over 4 minus, because this is negative, 50 over 4 plus 24 over 4. Okay? 25 minus 50 is negative 25. Plus 24 will give me negative 1 over 4. So, on this line, I am only coming down a quarter. So right there is my vertex. So now, as I come up, I'm going to make sure that I mirror my shape on either side, because that line of symmetry is a mirror. And then this would continue onward forever. From here, we can discuss something that a lot of students fear. Domain and range. Okay, so the domain is simply what x values I can plug in and make this actually work. Now, if you look at my function here, I can use all of these x values. And because it keeps going, I can keep going forever in that direction. Also, I can use all of these x values from the line of symmetry. And I can keep going in that direction using the x values. And it just keeps going forever. So, for the domain, you might see that somebody would say it's all the real numbers, because any value of x works, all real numbers. Now, in your program online, they tell you to write it in interval notation. So you need to say from negative infinity to infinity. Now, interval notation is kind of interesting. If you see a parenthesis, this means I cannot ever equal that value. So if I had 1, 3 with a bracket here, this is perfectly legal. I know it looks really weird to see brackets and parentheses together. This is because you're not used to seeing them separate. What this is saying is all the values from as close to 1 as you can get, but not equal to 1, close to 1 as you can get, all the way to 3. In fact, 3 is included. So this boxy shape means come right up to 3 and include it. This means get really, really close, but don't touch it. Okay? So my question to you, can I ever reach infinity, negative infinity? The answer is no, because as soon as you say, okay, I'm at negative infinity, I can go one step farther and pick a number bigger than that, or more negative than that. So you can never be at negative infinity. So this is a parenthesis, because I can't get to negative infinity. For the same reason, if you pick some positive number, say that you are at infinity and that number is as big as it goes, I simply say it's your number plus 1 and I'm one step farther than you. And thus, you are not really at infinity. Infinity is this number that never ends. It just keeps increasing and increasing and increasing. Kind of like the United States debt right now. It just keeps increasing and increasing and increasing. Okay? This is what we're talking about. We are never going to reach the cap there. So we never really reach infinity. Now the range is the y values. So let's take a look at this. What y values can I get? So if I take a look, this y is acceptable because it's got a line there. This keeps going forever, so this y is acceptable. And all the way up to infinity, they're all acceptable because this line is going to keep increasing forever. So all of these positive ones are fine. So I can say that I'm going to go all the way up to positive infinity, but what's the lowest y I can get? So when I look at this, I can come all the way down and y can be 0 because I've got zeros there. And if I go a little bit lower, you can see y can be at 1/4. Y can be at negative 1/4. But I can't go beneath it. As soon as I go beneath 1/4, I can't be there. So negative 1/4 is my cutoff. that comes from my vertex. Now, can I equal 1/4? I've got to ask myself, does this line ever reach negative 1/4? And the answer is yes. So I get a bracket on 1/4. Now, you may see, and the book may show you something like y is greater than or equal to negative 1/4. Alex will want it like this. So give the range this way. Also, be sure you don't put infinity and the negative 1/4. They have to be in increasing order. Otherwise, it will mark you as wrong. All right, you ready to move on? Just a little bit, not too much farther. Well, before I turn the page, I want to take a look at these. I want to look at the A's this time. So coming up here, A here is a positive 2. This creates this shape going up, like this. This one is a positive 1. It creates the shape going up like this. But there are two more cases. What if, for example, I had A equal to 0? What would happen to this thing? So if A was 0, 0x squared would go away, and this would simply be a line. This is mx plus b. Okay, this is just a straight line. So I would lose my quadratic equation. So A cannot be 0. Otherwise, why are we talking about in quadratic functions? Okay, and so my other option is A is less than 0. So A is negative. If you see something where A is negative, it's going to flip this shape. Okay? If I had this equation as A is negative, it would actually go something like this. Let's see, I'm at negative 3, so I'd be at positive 3. Not exactly, but it would do something kind of like this and flip the graph over. It wouldn't exactly flip it. There'd be more moving. This is just taking a negative sign to everything, and that would make this positive. So it wouldn't exactly be that, and I shouldn't draw that and say that that's what it would be because it's not what it would be. So let me show you. If it were negative, it would actually do this. And it would point down from the same vertex. So, if A is negative, I get a cup down shape. If A equals 0, I get a line. If A is greater than 0, positive, I get a U shape. Okay? This will become important for our next question. For the following, determine if there's a maximum or a minimum. Find the maximum or minimum of the function and state the domain and range of the function. So, notice here if I have this shape. A is greater than 0. It's this way. There's going to be a minimum point down here. The vertex is going to be the lowest point I can get, kind of like this one. The vertex was the lowest point I could get. And if I have A is less than 0, A is negative, then this vertex is going to be the highest point I can get. Now, because we're dealing with polynomials, because this is a quadratic equation, a kind of polynomial, the domain is always going to be defined everywhere. There will be times when we deal with domains that are not, but this is not one of those cases. Right now, we're really focusing on the range. So, if I look at this, I'm going to start by looking at A. Is A positive or negative? In this case, we have a positive 2. So, I'm in the case A is greater than 0. That means I'm going to have this shape, and that means I'm going to have a minimum. Okay? I'm just going to leave it as min so I have more space. So this is part A. We have a minimum. Part B, I need to find that minimum. So I need to find that max or min of the function. To find the maximum or minimum, I need the y value. To find the y value, I have to know the vertex. To know the vertex, I have to find that line of symmetry. You see where this is going? So, the line of symmetry is x equals negative b over 2a. Negative b over 2a. This is negative 4 over 2 times 2 equals, this is nice. 2 and 2 is 4, and so I've got negative 4 over 4, which is negative 1. But that's not the end. I now have to find the function value for this. Okay, so I'm going to plug negative 1 into this. 2 times negative 1 squared plus 4 times negative 1 plus 7. So negative 1 times negative 1 is 1, so I'd get 2 minus 4 plus 7. 2 minus 4 plus 7. 2 minus 4 is negative 2 plus 7 is 5. Okay, so the minimum value, the minimum function value, go ahead and just give it as a point. Negative 1, 5. Okay, that's my minimum value. The y will be 5. That's the lowest I could get. So if I was trying to minimize the cost for a production or something, my minimum cost would be 5. All right, next, part C. State the domain and range of the function. Well, if I know this is the lowest value I can get, then I will be able to say that for my range, at least, range, this is the lowest value I can get, so I can think y has to be bigger than or equal to negative 1. So now I can write it in the correct interval notation, and I can say it can equal negative 1, and then it's going to go all the way up to infinity. And then I can deal with the domain. And the domain, because I'm dealing with a polynomial, is all real numbers. All right. Next, I'm going to do the same thing with this one. So I was able to state the domain and range, find the minimum, and find that it had a minimum. So I'm looking here, and now my a is less than 0. So a is less than 0. This means I have this shape. It's pointing down, emptying out. And that means I'm going to have a maximum. Okay? So this is part A. Part B, I need to find the maximum function value, the maximum of the function. Part B. So I need to again find that vertex. To find the vertex, I need to find the x value. To find the x value, I need to use that axis of symmetry. So x equals negative b over 2a. Noticing a pattern here? All right, this is negative 10 over 2 times negative 5. Ha! We got lucky again. Negative 10 over negative 10 equals 1. Yes, I chose ones that I could plug in easily. You have fractions here. It's okay. Fractions are fine. I was after quick examples for you to see how to do the steps and not necessarily see all the fractions this time. I worked on fractions and that kind of stuff last time. All right, so I have my 1. I plug it in, and I put negative 5 times 1 squared plus 10 times 1 minus 6. Negative 5 times 1 squared gives me negative 5 plus 10 minus 6. This is negative 11 plus 10 is going to give me negative 1. So my point is going to be 1, negative 1. So the maximum I can get is negative 1. That means this entire graph is beneath the y-axis. To give you a picture of this, here's my graph. This is my vertex is at 1, negative 1. And that's also my axis of symmetry, so it's going to come down like this. Probably it'll go out faster, but yeah. Like that. That is the graph I'm talking about. There is no positive value for this. If you have a business and you have a expenditure or something that looks like this, you're going to go bankrupt. All right, and now I need the domain and range. Part C. Domain. I am dealing with a polynomial. A polynomial means it's defined everywhere. So this is all real numbers, or in the interval notation, negative infinity to infinity. Range. Okay, the range I'm going to deal with is anything that's lower than my maximum. Okay, so y is going to have to be less than or equal to my maximum value of negative 1. So this range is going to be negative infinity because I can go down forever and I can't ever reach negative infinity. And the highest value I can get is negative 1. And I can equal negative 1. All right. Seems like a lot, doesn't it? Well, this is just the graphing part. Only half the lesson. The other half. Solve by factoring, because we also need to be able to solve these problems. So, factoring. When you're factoring, you need to be able to take this value and this one and try to find a way that they can create the center value. Your goal is to be able to write this into parentheses. All right. I'm going to explain to you a couple tricks that I have learned over the years, and this is a pattern that I have found. When this is positive, this sign tells you if the two signs that you're going to deal with match or not. If this is positive, then the two symbols are the same. If it's negative, they're different. So here I have positives, so my two symbols are the same. If this is positive, then this is the symbol we're dealing with. Since this is positive, that means I'm going to have two positive symbols. If this is positive and this were negative, then both of them would become negative. Because this positive simply tells you that the two symbols are the same, they match. If they are negative, then this symbol tells you the value of the largest number, or the number that's farthest from 0, the one whose absolute value is the greatest. Okay? We've got one of those here. This one's negative, and this one is telling me the larger number has to be positive. So this told me that they're different. This one, the larger number, has to be positive. But we'll get down to that one because I want to show you a trick with this. So the next thing is the AC method. It's a method we have done before, kind of. I haven't described it as the AC method. I hadn't really verbalized it until after I finished teaching this stuff. And I'm like, oh, that would work. So this is a 1 here. And this is a 6 here. I'm going to think of 1 times 6 equals 6. What are the factors of 6? Well, I can go 1 and 6. I can go 2 and 3. And that's it. And then, because these symbols are the same, and they're both positive, I'm going to simply add them. Okay? 1 and 6 gives me 7. 2 and 3 gives me 5. Well, 5 matches my B. So this one's the one I want. So I want x plus 2 and x plus 3. Now, there's a special property. We call it the zero product property. Okay? The zero product property means that if I have A times B equals 0, then either A equals 0 or B equals 0. Okay? They both can be 0, but at least one of them have to be 0 to give this result. So, using the zero product property and knowing that this will equal 0, I can now set this to 0 and this to 0. So, x plus 2 equals 0, x plus 3 equals 0. Then I get x equals -2, x equals -3. Those are my solutions. I just solved this. The other thing I want you to know about this is I want you to understand what this means graphically. So earlier, I had us graph this same equation. So this equation is this one here that we graphed. Take a look. This means that this actually comes out and crosses 0 at -2 and it crosses 0 at -3. Okay? That's what this means. These are the x-intercepts. These are x-intercepts. Okay? These are the values. It's very important that you get that because you may be asked to find the x-intercepts and not to solve. That simply means that you have to change the f of x to 0, find where y is 0, and solve this part. All right. Completing the square. This is a topic that can throw people for a loop. But in reality, it's a very simple idea. So I want to go over what the idea is of completing the square. So I'm going to start by drawing myself a square here. Now, you guys should know that the area of this square is this side times this side. Area equals the side squared. Okay? But what if I changed my sides? What if I made this square into pieces like this, where I had x and h, this is an x and this is an h, okay? So then my side would be x plus h. X plus h times x plus h. So I need to be able to do this, and this gives me the square. Now, we could FOIL this, or I could show you where the FOILing actually comes from using an area method, because you guys have learned FOILing, but you probably never understood what it meant. So here, using this picture, I can show you what FOILing actually does. So here's one side, and here's the other side. Well, then this piece right here is x squared, x times x. This piece right here is x times h. This piece right here is h times x, but I can write it the other way, xh. And then this piece here is h squared. So when you're FOILing, you're actually finding the area of 4 different pieces. Sometimes it's a rectangle, sometimes it's a square. In this case, it's a square, but this gives you the idea. So when you're factoring it, you're simply trying to find what created this and what created this so that you had the two that you added. So when I look back up here, I can actually draw this. I had an x squared, where this is x and x. And then down here, I had 6 ones, where these are all ones. And then I had to put my 5 x's somewhere. So there's 1x, 2 x's, 3 x's, because this is 1 x. This is a 1 here, a 1 there, and a 1 there. And here's the other 2 x's. And a 1 there and a 1 there. And from this picture, you can actually see this is x plus 3, and this is x plus 2. I'm showing you this because completing the square relies on an understanding here of the shape. This is where the geometry and the algebra have to go together. So looking back down here at my shape, I have this. So this will become x squared plus 2hx, because I have 2 of them, plus h squared. Yes, I should have listed it the other way, but it's okay. So I have this. This will give me a square. But normally, I am given it in the form ax squared plus bx plus c. If I'm given my equation in this form, I have to be able to find this form. And that's not always the case because c doesn't always work. Sometimes c is very annoying and irritating. But I need to make b work. So if you notice here, 2h has to equal b. So 2h equals b. That means h has to equal b over 2. This also means that h squared has to equal b over 2 squared. I'm explaining this because these are the formulas that they give you. Often they say, oh, complete the square. Take b, divide by 2. That's this value. Square it. That's what you have to add to both sides. Well, that's not always useful because you don't know where this came from or why it's there. So I'm going to take this, move it down here so that we can solve completing the square over here, one problem. Okay, so ax squared plus bx plus c. Now, if I look at my problem, I can see a equals 1. In order for the square to be completed correctly, I need this to be 1. If this is not 1, I'm going to have to divide, and I'll have to do this with fractions. It is possible, but very highly annoying. Okay? But this method, if you understand it, can go faster than plugging this into the quadratic equation. And you can look at this and say, can I factor this? So you're looking at it and you can look at it and it's like, I can't factor this because no value, because 3 is just 1 and 3. And no matter what I do, I can't get 6 from that. So this is not factorable. And so then you'd have to do quadratic equation. And that means a lot of calculator work, a lot of possibility of error, a lot of all kinds of stuff. And sometimes this can simply go faster. So my first job is to get rid of this c because this c bothers me. Great. So I'm going to say x squared plus 6x equals 3. Simply move the 3 over. Now, I have a b here. I know this b has to equal 2h. Well, this is 2 times 3, right? So here, 2h is 2 times 3. That's a 2 times 3. So my h here would equal 6 over 2 equals 3. H squared equals 9. These are important now. So to put it in this form, I need an h squared. So I am going to write x squared plus 6x. I'm going to add my h squared plus 9 equals 3. Now I added it over here, but because it's an equation, I have to do the same on both sides, plus 9. So now this is x squared plus, or sorry, not x squared, x plus 3 squared, just like this. I put it in this form, so now I could write it back in this form. It's just squared. And this is 12. Square root both sides. and I get x plus 3 equals. Now when I take the square root, I don't know if I need the positive root or the negative root, so I need to go plus or minus square root 12. Well, do you remember yesterday when we did square root 12? Well, for you it was yesterday. For me it was just like 20 minutes ago. So square root 12 we know is 2 root 3. So I'm going to move this over here and I get x equals 3 plus or minus 2 root 3. And that would be my solution. Do you see, this is a lot easier to plug in if you understand where it comes from. So then I wouldn't have to work on the quadratic equation quite the same way. It's very important because it can be a shortcut. Not always, but can be. And this method is where we got the quadratic equation. By doing this method to this equation, you will find the quadratic equation. That is the key. Without this method, you would never have the quadratic equation. And you can see this is a lot shorter than what we are going to do next, which is the quadratic equation. Yes, I know, this lesson is long. Okay, so solving using the quadratic formula. All right, this quadratic formula, do you remember it? Because if you don't, that can cause this to become very difficult very quickly. So, if you run into a problem, the first thing you do is you try and factor it. If factoring doesn't work, if this is 1, and especially if this is 1 and this is even, just complete the square, it's faster. If this is 1 and this is odd, it's kind of a toss-up because now you got to deal with fractions, and depending on how good you are with fractions, that can get annoying. But if this is not 1, and when you divide, you have fractions, it gets complicated very quick and you don't really want to deal with it. So, quadratic formula. It is the line of symmetry, negative b, 2a, and then it's just like this where I add the plus or minus square root, okay? This is plus or minus square root of b squared minus 4ac. Okay? That is my quadratic formula. So, shall we solve? 2 is a, 3 is b, 5 is c. So, x equals the negative b, so minus 3, plus or minus the square root of b squared, 9, minus 4 times 2 times 5, all over, oops, I don't want it to go across the equation, that doesn't work, all over 2 times 2. Whew, this is a long one. Can you tell already? Okay, x equals negative 3 plus or minus the square root. Okay, 2 times 5 is 10 times 4 is 40. So 9 minus 40 all over 4. Okay, 9 minus 40 is negative 31. X equals negative 3 plus or minus square root of negative 31 all over 4. Well, many of you would look at this and say, oh, we're done. We can't do it because we can't take square root of a negative. No, you can do that now. Remember, we just learned all the complex numbers. So this is the same as saying negative 3 plus or minus the square root of 31 times the square root of negative 1 all over 4. That's right, these are complex numbers now. So this doesn't have any real roots, but there's complex roots. So negative 3 plus or minus square root 31 I all over 4. Well, now that you're in complex, we have to write the number properly. The proper way to write a complex number is a plus ib, or a plus bi. So I need in the form a plus bi. That's in the wrong form. So x equals negative 3 over 4 plus or minus, because there's two roots. It could be plus 31 over square root 31 over 4, or it could be minus square root 31 over 4i. Two complex roots. Now, this is a bunch of number crunching. Your calculator, if you plug it in here, is going to say, I have no clue what you're saying because this doesn't exist, because your calculator doesn't know how to do complex numbers unless you tell it to. So, you would type this in, you'd get do not exist, and then you'd have to do all this work anyway. One quick thing to do is simply find this answer. If you can find this answer, say 9 minus 40 equals negative 31, then you can know that this is I, and you could simply write it with a 31 in here. And then it would tell you your possibilities, and you would have to add the I. You also do not want it to simplify, because if you're not careful, your calculator may stick these two together because they both look real to it. It's not both real. All right. That is the end of the lesson. I know it was long and crazy and so many different things. You can rewatch it if you want. Your homework is based upon both methods of graphing, being able to find the maximum and minimum, and all three methods of solving a quadratic formula, a quadratic equation. All right. Welcome to your first real lesson.